Hi, hopefully you have your notes ready to go. We're going to talk today about properties of functions. Primarily, we're interested in a couple of different things. Where is a function increasing? Where is it decreasing? Where is it constant? And what are the relative minimums and relative maximums? So let's start off by thinking of a function is kind of like a roller coaster. It has ups and downs, and you always want to think of it in terms of going from left to right, just like when you're reading a book. So in case you missed that, let me show that little dot again. So think of a function as going left to right, up and down. So there's a roller coaster, there's the function. So when a function is going uphill, in other words, when the slope is greater than 0, we say that is where the function is increasing. It's going up, it's increasing. Where a function is going downhill, that's where the slope is less than 0. That's where a function is decreasing. So that's the downhill. That's the fun part of a roller coaster. And where a function is neither going uphill nor downhill, in other words, where it's flat, we would say that's where the function is constant. So example questions. First, I would give you a graph, or you would have to graph something, and you would be asked to determine where is the graph increasing, where is it decreasing, where is it constant, and what are the local maxes and mins. So here's a graph. Your question is, where is the function increasing? So the function is going to be increasing where it's going up, right? So in this region right here, you see how that got dark? That's where a function is increasing. So we would say it is increasing from 0 to 2. We are only interested in the x values. We're not interested in the y values, just in the x values. Now, where is the function decreasing? Where is it decreasing? Well, it's decreasing from here to here, and also from here to here. So we would say it's decreasing from x equals 2 all the way to x equals 7. And finally, where is it constant? Well, it's constant in this region. So it's constant from 7 to 10. Next up, where are the maximums? Maximums occur at the top of a hill. So we would say this point right there, that is a maximum. So a maximum occurred at 2, 3. And where do minimums occur? Well, down here, that's a minimum. So we would say a minimum occurred at 0, -3. Now notice the difference here. These are ranges and their x values. These are points. And we could also say that there were minimums everywhere between x equals 7 and x equals 10 is a minimum, right? Nothing goes below a y value of -3. So everywhere in there would be a minimum, x equals 2 would be a maximum, and x equals 0 would be a minimum. So that's the way we would decipher that graph. All right, so let's do another one. Y equals -2x plus 5. This is by graphing on a calculator, determine where this happens. So what we're going to do is we're going to go to the graph. And so here's our first graph, y equals -2x plus 5. So you can look at that and you can see that that function is decreasing everywhere, right? It's decreasing everywhere. So we would characterize that then as decreasing. It is decreasing everywhere. If I go back to my screen, we could then say that this function, if it'll let me write, is decreasing from negative infinity to infinity, and it has no max and no min. Okay? So let's look at another one. So here's another one. We want to take a look at this one. Let's discard that and go back to our graph. Get rid of that graph. And let's take a look at this graph. I need to zoom in a little bit on this graph to see what's going on. So if I look at this graph you can see is increasing from negative infinity up to 1, and it's also increasing from 2 to infinity, and that it's decreasing from negative 1 to 2, and that there is a maximum at x equals negative 1, and there's a minimum at x equals 2. So it's, in this region right here, see where my pin's going? In that region right there, it's increasing. It's also increasing in this region right here. I can see where it's increasing there. And then it's decreasing in this region. That's where it's decreasing. And it's got a maximum here up at the top, and it's got a minimum down there at the bottom. Got a minimum right down there. So if we go back to our screen, for this function then, we would write it this way. It's increasing from negative infinity up to negative 1, and it's also increasing from 2 to infinity. It's decreasing from negative 1 to 2 to fill in the gap. It's got a maximum at x equals negative 1, and it's got a minimum at x equals 2. All right, so that's the way we characterize that. Let's do one more example. We're going to do this one. All right, so let me get out of here, discard all that, and let's go back to our screen. And let's take a look at this one, get rid of that one. All right, so if we zoom out a little bit, you can see that this one, if you take a look at the function, this function, it's decreasing. If you follow my pin, it's decreasing here. It's also, if you imagine on a roller coaster, it's decreasing here. So it's decreasing everywhere except right there at 4, 2, 4, 6, 8, 10. It's got a number of 4. So at 4, there's an asymptote. So it's not decreasing there, but it's decreasing everywhere else. And as far as mins and maxes, since this is going down and it keeps going down forever, and then this is going down, there are no minimums and maximums. This is going to infinity, and this one's just going to 0, but it keeps getting closer and closer and closer, and this just keeps going on forever. So there's really no minimums and maximums here. So for this one then, current slide, for this one, we would say it is decreasing from negative infinity to 4, and then also from 4 to infinity, and it has no max and no mins. All right, let's take a look at an application for this now. Let's go back and do that one more time. Current slide. All right, so here's an example. So a long time ago, Digitari, a great video game manufacturer, it determined the cost and revenue functions. The cost functions given to you there, the revenue functions given to you there. We want to determine the intervals on which the profit function is increasing. So for those of you that are a little bit familiar with business, you would know cost is how much it costs to make something. That's the money that the company has to spend. Revenue is the money that's coming in. That's how much money they make. Profit would be the difference between those two. It would be your money that's coming in, your revenue, minus your cost. In other words, how much you have to take home. So if we take a look at one more picture, here's our cost function. So the cost function, we need to zoom out so we can see it on the correct scale from 0 to 2250. All right, so there's our cost function from 0 to 2250. See, it goes like that. And then here's our revenue function. But our profit function is going to be revenue minus cost. So there's our profit function. And the question was, where is it increasing? Well, it's increasing along this, see my dot moving? It's increasing until right there, and then it's no longer increasing. Now it's decreasing. So it's increasing up to x equals, I'll move that along, up until it gets to 1,125. So we would say it's increasing from 0 up to 1,125. And then after that, it starts decreasing again. And we did that by looking at the graphs. So that's it. That's what you need to know about increasing, decreasing, and maximum and minimums. And we're going to practice this some more tomorrow.